Almost every single electronic product you touch. Think about your phone, or maybe something less obvious, like the machine checking government employees into work. Well, right now, it relies on foreign tech. We're talking about chips. And these tiny things, they represent a huge systemic national security risk.
Yeah.
It's happening right now.
It really is quite staggering when you look at how deep this dependence goes.
Yeah.
Well, it's the result of decades, really, of struggling towards technological sovereignty and, frankly, falling short.
A critical failure point, you mean?
Yes, the reliance is just so complete, and the scary part is how quickly it could be turned against us. Instantly.
Okay, let's try and unpack this then. Today, we really need to look at India's pivot here. It's urgent. How does a country known mostly as a services nation become a real product nation? Because it feels like we have to.
Exactly.
So we'll look at the history, some policy mistakes maybe, and these security threats you mentioned, the ones that actually happened. And then the big strategies, semiconductors, quantum, rare earths, all of it. What do we need for real independence?
Well, to grasp the current situation, you really have to go back. Back to what some call the hardware collapse. It's funny, most people don't even know that back in the 70s, 80s, India actually had a domestic electronics industry. We designed computers here.
We did. And then what happened? It just vanished?
Pretty much. It was effectively dismantled between, say, 1999 and 2005. This was after signing the WTO agreement. The big mistake, looking back, was that the government pushed for liberalization for cheaper imports for consumers, but without really protecting or nurturing our own manufacturing base. And crucially, they did this massive policy shift without really talking to the domestic industry first.
Right. That sounds like a familiar story sometimes. So while other places like China or Brazil were shielding their industries, we kind of opened the floodgates.
That's a good way to put it. Our choices basically wiped out our hardware ecosystem. We doubled down on services, maybe some cheap assembly, but not the core tech.
And now we're seeing the consequences. Real security risks, not just theoretical ones.
Oh, absolutely. The danger from foreign hardware, it's not hypothetical. It's already hit critical systems.
Okay, give us the starkest example you came across.
Right. So about 2 years ago, an intelligence agency found something pretty chilling. Those attendance machines, the ones used in central government offices to log people in and out.
Yeah, standard office stuff.
Well, data from those machines was being sent back to China because they had Chinese chips inside, easily available chips.
Hold on. Data on government officers, their movements, potentially their families, all compromised by a simple attendance machine. That's not sophisticated spycraft. That's just a basic vulnerability.
It is. And it's everywhere. Think about all the CCTV cameras across the country. Millions of them. Every street corner, every building.
Wow.
Potentially feeding information back because, again, foreign chips. When you depend entirely on imported hardware, you basically give up control over your own data space. It's that simple.
And this stretches right down to the things we buy, right?
Yeah.
It leads to this term, screwdriver technology, which sounds kind of insulting.
It is, in a way, because when you hear made in India for, say, an iPhone or a Samsung phone, often it just means we're assembling kits. Kits supplied from abroad, often China.
So we're not adding much real value ourselves.
Almost none. And that's the economic weak spot. About 60% of our economy is in services. Well, it's dangerously high.
A services trap.
Exactly. So the goal can't just be manufacture in India if that just means assembly. It has to be design and manufacture in India. That's how you build value, use the skills we actually have.
And we do have skills in this area, right? It's not like we're starting from zero.
Not at all. That's the irony. India is the second largest chip design hub globally. We have huge R&D centers for NVIDIA, AMD, Intel, plus our own giants like TCS, HCL, Infosys are doing complex design work.
So the brain power is here, the engineers are here.
Yeah.
But they're designing for export, mostly, not for our own products.
Largely, yes. That's the disconnect we need to fix. So for tech sovereignty, especially in semiconductors, there's a path we need to follow.
Okay, what's the roadmap look like?
It's a sequence, really. You start with the final system, the actual device. Then you go back to the chip that powers it. Then to the fab, the factory that makes the chip. Then packaging it. And finally, capturing the market. System to chip to fab to packaging to market. Okay,
let's quickly define fab and packaging. People hear these terms, but what do they actually mean?
Good point. So the fab, that's short for fabrication plant, it's the ultra-clean facility where the magic happens, where circuits are etched onto silicon wafers to create the actual chips. It's incredibly complex.
Right, high-tech manufacturing.
Exactly. And packaging sounds simple, but it's critical. It's about taking that delicate chip, putting it in a protective casing, adding the connection so it can actually be put onto a circuit board in a phone or a missile or whatever, making it usable, basically.
Got it. Now, part of the government strategy involves banning certain chips, right? Chinese chips specifically, because of those security risks, the back doors. But isn't that risky? If we ban them before we have our own, won't that just break everything?
They know that's a risk. The proposal isn't just a blanket ban tomorrow, it's more nuanced. Ban the chips known to transmit data illicitly, yes, but only implement that ban once reliable domestic alternatives are actually ready and available.
Okay, so the pressure is really on developing those domestic alternatives fast.
Precisely, which means we need to talk about incentives. How do you get companies, especially startups, to design the chips we need here, not just for export?
What are we doing now, and is it enough?
Well, there's the Design-Linked Incentive Scheme, the DLI, under the India Semiconductor Mission, but the current payout, around 30 crore per chip, frankly, it's not enough for the really cutting-edge stuff.
It sounds like a lot, but maybe not in the chip world.
For complex advanced chips, no. The R&D is incredibly expensive. To really move the needle, especially for startups taking huge risks, that incentive probably needs to go up significantly. Maybe 50 crore, 100 crore, even 200 crore for the most advanced designs. That level of support makes the economics work against the global players.
Okay, so boosting design incentives is key. What about the raw materials? You can't make chips or batteries or EVs without certain elements. The sources mentioned rare earths.
Ah, yes, rare earths. They're calling them the new gold, essential for almost all modern tech. And here's the problem.
Let me guess. China.
China. They control something like 90% of the global supply. That makes rare earths a potential weapon. They could just turn off the tap. Halt production of EVs, batteries, defense tech worldwide.
That's a massive strategic vulnerability.
Yeah.
So are we just stuck, or is there a way around it? Mining takes forever.
There's actually a very clever, faster solution being discussed. It involves e-waste.
E-waste, like old phones and computers.
Exactly. Instead of digging new mines, which is slow, expensive, and environmentally challenging, we can extract those vital rare earth materials directly from the mountains of electronic waste we already have.
Recycling on a strategic level.
Precisely. It's a non-mining approach. Estimates suggest we could meet maybe 30% to 40% of our national need this way, much faster than starting new mines from scratch. It's practical, and it's here.
That makes a lot of sense. Okay, so we have materials, we need design incentives. What about the people, the engineers? We hear about layoffs in the IT services sector. How does this shift to a product nation help them?
It's absolutely crucial for them. Building products needs engineers, lots of them. And to fuel this, there's a massive government initiative. It's called the Research and Development and Innovation Fund, or RDI Fund.
RDI fund, what's the scale?
It's huge. Ours 1 lakh crore.
Yeah.
Set aside for 50 years. And here's the kicker. It's interest-free.
50 years, interest-free. Wow, that's effectively much more than 1 lakh crore then over that time frame. That's serious long-term commitment.
It absolutely is. Plus, it's designed with matching funds, 50% from the government, 50% from the corporation involved. So the total impact is potentially enormous. This is the kind of long-term capital you need to build truly great products. Indigenous drones, next-gen EVs, advanced defense tech.
Okay, the money's potentially there. But big funds sometimes just end up with the big established players, right? How do we make sure this actually gets to the startups, the innovators who need it most to scale up, and doesn't just get absorbed by, say, TCS or Infosys?
That is the million-dollar question, or maybe the lakh crore question. We have the capital potentially, but we absolutely must fix the policy roadblocks that just kill startups when they try to grow. The analysis points to 3 big ones.
Right. Let's break those down. What's the first hurdle?
It's the need for huge bank guarantees. Imagine a startup wins, say, an 11 crore defense contract. Great news. But then they're asked for a 9 crore bank guarantee.
9 crore. How does a startup come up with collateral for that?
They can't usually. They don't have the assets. So they're forced to use precious capital, maybe money raised for R&D, just to secure the guarantee for the contract they already won. It stifles growth.
Okay, so they're burning through innovation capital just to fulfill orders.
Yeah.
What's the second problem?
It's directly related. There's no proper working capital policy tailored for these innovative startups, especially those working on big government projects with long payment cycles. They win the business, but then they struggle to fund the actual work without
Selling off chunks of their company.
Exactly. They end up diluting their ownership, taking VC money just to manage cash flow on projects they've already secured. It's inefficient and puts founders at a disadvantage.
Right. And the third hurdle, This one's about talent, I believe.
Yes. It's about attracting and keeping top engineers. It comes down to ESOP's employee stock options. The way they're taxed in India is, well, problematic.
How so?
Currently, employees have to pay tax on the value of their stock options when they vest, meaning when the options become available to them.
But they haven't sold the stock yet. They don't actually have any cash.
Precisely. They have zero cash flow from those options, but suddenly they owe tax based on a paper valuation. It forces them to sell shares early just to pay the tax bill or face a huge liability they can't afford.
That seems completely counterintuitive. It discourages holding on to the stock.
It totally undermines the whole point of ESOPs, which is long-term alignment and wealth creation. The global standard, pretty much everywhere else, is you pay tax when you sell the stock, when you actually have the money. Fixing just this one thing would make a massive difference for startups competing for global talent.
Okay, so fix the guarantees, fix the working capital, fix ESOPs. Let's assume we do that. We start making great products. How do we then compete globally? How do Indian companies become world leaders, especially in critical areas like telecom or energy tech?
One word: demand aggregation. The government needs to become the anchor customer, a big anchor customer.
What does that actually mean, demand aggregation?
Think about it this way. Instead of every government department, every state enterprise, every public school buying its tech separately in small lots,
Uh-huh.
the government consolidates a huge chunk of that demand, say 50% to 75% of the total national requirement for certain products, and guarantees that volume to qualified Indian companies.
One massive order.
Yes. That guaranteed volume allows Indian firms to scale up production rapidly, achieve economies of scale, get their costs down, and become competitive almost overnight.
Is there a precedent for this? Did anyone else do this successfully?
Absolutely. Look at Huawei in China.
Right.
The Chinese government basically gave Huawei all the domestic telecom contracts early on. They guaranteed them the home market. Then they backed them with huge lines of credit to expand globally. That's how Huawei became the behemoth it is.
So India needs to do the same for its potential champions,
Yeah.
like Tejas Networks or Tata in the tech space.
Exactly. Give them the domestic scale, support their global push, and we have an advantage now that China didn't have initially:
Which is,
trust. In critical infrastructure, 5G networks, power grids, cybersecurity, countries in the West and many others are increasingly wary of Chinese technology. They'd likely be far more comfortable using Indian tech.
that's a really important strategic edge. We can leverage that trust.
Definitely. Okay, so that's hardware, software strategy. But we can't ignore the next frontier, the really big one: quantum.
Quantum computing. India's making a big bet here too, isn't it? With the National Quantum Mission, the NQM.
A very significant bet. We're talking about an investment around 6,000 to 7,000 crore, and the reason is partly defensive.
Defensive, how so?
Because a powerful quantum computer, once built, could potentially break almost all current forms of encryption. Instantly. All our secure data, financial systems, military communications, vulnerable.
Okay, that's terrifying. So the mission is to build our own first, or build defenses.
Both, really. The goal is to develop a 1,000-qubit quantum computer here in India within the next 5-6 years. And at the same time, develop quantum-secure communication methods to protect ourselves against quantum attacks, whether from our own future computers or someone else's.
Beyond the cybersecurity nightmare, what are the positive applications? What will quantum actually do for ordinary people?
The potential is vast, but one of the biggest near-term impacts could be in healthcare: drug discovery. Quantum computers can simulate molecules and chemical reactions with incredible speed and accuracy, something classical computers struggle with. This could drastically cut down the time it takes to research and develop new medicines. Imagine reducing drug development from, say, 15 years down to maybe 5 or 7 years.
That would be revolutionary. Cheaper drugs, faster cures.
Exactly. Cheaper healthcare, faster innovation across materials science, finance, logistics. The possibilities are huge.
So wrapping this all up, it feels like there are maybe three big pillars here.
Yep.
First, a real national shift in focus.
Yeah.
Design and manufacture, not just assembly.
Right.
Second, the government stepping up as a massive strategic buyer through demand aggregation.
Crucial.
And third, fixing those nagging problems that hold back startups. The bank guarantees, the working capital issues, and definitely that ESOP tax rule.
You've got it. Those are the levers, and the urgency is there now. The security risks aren't theoretical anymore. Those attendance machines, the CCTVs, that's real evidence. It provides the political will, perhaps.
The kick on the backside needed.
Maybe so. And you combine that urgency with the massive RDI fund, the focus on design, the quantum mission. It feels like maybe the pieces are finally aligning for a serious attempt at technological sovereignty.
It does feel different this time. But the big question remains, doesn't it? We have the money, we have the plan with a wake-up call. But can a democracy like India maintain that kind of focused, long-term, almost state-directed push, the kind that built Huawei over political cycles and economic ups and downs? Or will that focus inevitably get diluted? That's a real test, perhaps, over the next 5 years.
That is indeed the critical uncertainty. Commitment and execution are everything now.